for the Bitcoin technology as because it has given a boom to the blockchain technology. Bitcoin has given a boom. It's a one technology which has given, it's an application which has given a boom for the technology, which is nothing but what? Bitcoin. So Bitcoin transaction, if you have to mine, in that case miner needs 10 minutes time. And if the same scenario we are expecting in the blockchain technology for the healthcare sector, think what will be the scenario. If any decision has to be taken, just like today you have gone with the consent checking of the patient, and if patient has given a consent after 10 minutes and he has already heart attack over there, okay, so that's why sharding is required there. And in sharding, just what we are doing, we are preparing the groups of or partitions of the networks. So if this is what the scenario, this is a traditional approach which is used by the blockchain technology. We are starting with the traditional approach, and there is a single chain which is providing us a low throughput, high latency and increased cost issues. Because all the nodes are ready only to fight the one transaction, and they are validating only one transaction, which is going to be consume so much cost, which is going to be slower down throughput over there, which is going to be increased latency issues. To solve these, suggested approach is shared blockchain. In shared blockchain, you are preparing some shards where network you are going to be finalized. How many blockchain network elements you have to be provided over there, and the shards are going to provide final data to the again central network where all are accumulated. And that accumulated data is then given for the rest of the world. And again, what is the advantage of it? Increased throughput, reduced latency and lower cost. So, exactly how it is happened. Initially, you need to prepare over the shards. After preparing shards, transaction processing is given for the each and particular shards over there. Then, cross shards communication are going to be takes place when you need to add the blocks. Okay, why I am saying about the addition of blocks? Because there is a one condition, orphan blocks as well as forking issues. Okay, so if we are saying about the orphan blocks, exactly what is the meaning of orphan block? All miners are ready, they are ready to mine the blocks, but being a miner, one miner has thrown the block, validated, another miner again has thrown the block. Do you know what is meant by 51% attack issue in the blockchain, which is majorly means problem for the blockchain technology? 51 people will come. If we are assuming a stake of 100 people over there, 51 people will come over there, and who are going to expand the chain? If I am assuming about a block linked list addition over there or condition over there, block addition condition. In that case, first block is there in the chain, second block is there in the chain, third block is in the chain, and who is adding this block? Miners. So now miner 1, miner 2, miner 3, likewise you have n number of miners. So here, among these n number of miners, if I am saying about 100 miners, among them 51 miners are in a one group, okay, and 41 miners are in another group. So due to that 51, if block 4 has expanded and now 41 again given another block, 51 will carry forward this block, and if this is what the condition, this block is going to be orphan later on. Because 49 people are with this particular block, rest of the people are with this block, and that might be a possibility after this transaction, these transactions are getting different over there. So now to whom has to be decided? Then we will go with the majority issue over there, and if this particular one is faulty or malicious, in that case what? Means to address the issues of orphan block, to address the issues of forking, we need to go with the sharding approach. Is it clear why the sharding is assumed over there or expected to have? Means only tamper-proof data, only working on the security aspects, only providing a solutions for the data privacy concerns. It's not the only aim of the blockchain technology. Apart from that, blockchain technology needs to be focused upon these technical aspects. That may be from the operating system issues, because we are involving to the cloud environment. So these issues need to be addressed by the operating system. If we are saying about that, yes, if my data is there in the distributed environment, in that case you need to be focused upon the distributed aspects. If you are assuming that conscience mechanism involved over there, then we need to be involved over there, a conscience mechanism or algorithms over there for working. So these are the domains where we can work apart from it. Am I clear with this? Then conscience mechanism. Which conscience mechanism we are electing for particular sharding process that is in your hand over there. Then data availability. To whom you have to make the data availability over there, as we have prepared initial shards over there. So if this is what the condition, then if you have some data over there with respect to the shard, it is going to be processed. Now what are the types of shards? State shard, transaction shards, network sharding or dynamic sharding. Okay, so state sharding is just dealing with what your static data. Static sharding, it's itself a not state, it's a static state sharding which is going to be deal with the static information over there. Transaction, whatever the information or entries we are including over there, it is about that. Then networking, as we already stated over there, minus if involved over there, then for that they will. So why we need to discuss about this sharding? Already I have stated for high data throughput, low latency, security and legality compliances. Challenges. As for that we are using the sharding, that are nothing but what we have assumed in the paper challenges for it. So what exactly sharding improves in data transmission, or why sharding improves data transmission? So if sharding is involved, initially what it will improve scalability in terms of what? Parallel processing and reduce congestions. Parallel mechanism is definitely going to mine 3 or 4 blocks at the same time. Central repository is finally going to be added. Okay. Then reduce congestion is nothing but what? From if one end you are just moving, in that case automatically there will be a block. So delay will be more. To avoid that delay, what we are doing? We are preparing a shards. Then lower latency, localization, transition, which is nothing but what? Taking lesser time for the validation. And optimize for IoT. Why we are assuming for the optimization in IoT particularly? Because in IoT so many devices are connected from so many users. And if they are continuously giving data over there, in that case, which transaction you need to be validated? That is again one of the major concerns. Enhanced security, distributed data storage, because again these are the IoT devices. And the IoT has which lacuna over there, that's security aspects. So through this particular blockchain sharding technique, we are providing the security to the IoT devices. Energy efficiency, why? Because we are trying to reduce computational load. I hope you might have gone through the article published by one of the interview given by the Elon Musk, that blockchain is consuming so much electricity. Uske baad se, am I right? So why this statement he has given? Because whenever we are saying about the Bitcoin, in Bitcoin so many miners are there in competition at one time, so their resources are continuously utilized, and due to their continuous resource utilization, automatically electricity is involved, and that's why always we need to think about energy efficient solution in the blockchain. And interoperability issues. Why interoperability? I am a user of this particular blockchain provider platform, and another organization is using different one. In that case, they need to mutually transfer data. That's why some of the regulatory issues you need to be considered over there, and with respect to that, share of data. Then cross-shared communication has to be takes place over there. Optimize blockchain sharding for the healthcare, that provides what? Dynamic sharding, shared specific conscience mechanism, data optimization, security enhancement. Now, whatever the title of the paper, before discussing for the paper, I have cleared some of the fundamentals about this particular paper. The title of the paper is Improving Data Transmission Through Optimizing Blockchain Sharding in the Cloud IoT-Based Healthcare Application. And that paper which is we have selected, it has impact factor 4.3 and cites for 11.8 and recent published journal. Okay. So this paper improves data transmission. Means whatever data you have to transfer, if that transfer you are dealing with that, automatically what it will do? It is going to be reduce the time. So if it is about what are the contribution of these two authors or two researchers. So they have given a protocol, ADASEC, health protocol to address scalability issues in the blockchain technology in high throughput and low latency applications. This particular interest were in scalability improvement only for 2 parameters. We are not saying about so many elements over there. If you are providing 0.1% contribution, even it is much more for the researcher. They are not expecting rocket science over there. Okay, ECAO, Enhanced 40 Optimization Algorithm for selecting shards. To address orphan blocks, forks in a shard network. If there are any, what we can say that orphan blocks or any type of forks over there, in that case how it is going to be addressed, it is going to be decided by this particular algorithm. And finally, integration of ADASEC and ECAO will provide efficient solution for balancing fork probability and user experiences through the latency and throughput time. So, the given block diagram or the given, what we can say that framework by the authors or by the contributors, that they have set up initially some what we can say that protocols over there, and for whom they have decided, authorities are there, participants like patient, doctors or nurses, or what we can say that the people who are there in the blockchain in the area of healthcare sector, they will be utilizing it. So that's why they have said over there patients and collaborators. So patients are nothing but what? A provider of information over there, and collaborators whosoever is involved like a doctor, they will create a chain, they will be asking to have the records, and collaborators are going to provide this data to access emergency servers and call agents that data, not as by the patients. Means data is going to be given by the collaborator as on when there is a requirement with the consent of patient. If this is what the condition, then who is going to do the conscience mechanism and where? So for doing conscience mechanism, we are going to use what? One of the, means not exactly doing the conscience mechanism. Before having that conscience mechanism, what there will be a condition? Network of shards. Or what we will do? We will partition a network over there. After partitioning, there will be miners in that particular shard who are going to be validated document. After validating that document, it is going to be stored in the IPFS format, which is nothing but what? Interplanetary file system, which is going to provide you hash values for the each and every transaction. Yet not we discussed about the hash function. Where we will be adding it? After the shards. Is it clear? Because once we thought about the blockchain technology, SHA-256, no. Apart from that SHA-256, there are so many algorithms are in the existence, and even this file system provides a hash function. If this is what the condition, the main focus is on whom? Are storage and providing the sharing of that particular data. So in storage, EHR is going to be created by the collaborators, that are nothing but doctors or the people from the healthcare sector. They will create EHR and that will be given to whom? To the patients, where they will be storing their data in IPFS format. Now what exactly that data? Their readings, healthcare devices, whatever they will be accessing the hospitals, because whenever they will enroll over there in the hospital, initially what they will be asking? Either patient name or ID. So who is contributing for the data? Definitely a patient. That's why who is the main provider of the data in the storage phase? Patient. Patient considered over there. After that, with that patient, there is what? EHR metadata. Now, in this phase, particularly, we are encrypting our information. Being a patient, we are really interested to have all the information to all people, as because there is a condition in earlier phase given over there, they are sharing the data. So to avoid that publicly available of information, there is what? An encryption algorithm included. And so we are saying the SHA is there should be some certification, there should be some signatures. So these all the things we are incorporating, but where? In rest of the phases, wherever it is required. And which algorithm it is going to be used? CPABE, Ciphertext Policy Attribute Based Encryption Algorithm, which is encrypting the data, and that will take lesser amount of time for the encryption over there. And who is going to generate hash function? IPFS, file system itself. And in case of sharing phase, patients are going to share their metadata in blockchain to the collaborator whenever they have a given consent. and after that they will retrieve. Now who is involved over there for providing the consent? Who is involved for providing the consent? Patient. But on which basis he is providing the consent? So for that there we are utilizing two terms, public key and private key. Okay. So these terminologies are automatically assigned there, but we are not aware about it. That when we are using a public and when we are using a private. But being a technical people, we are aware about it. That this is my public ID and this is my private key. Okay. The collaborator verifies integrity of the record comparing the hash value. On whom we are always checking integrity of the system? Hash function. Hash is very important as we are saying over there in the blockchain technology. जब कभी भी blockchain technology start होता है, सबसे पहले word होता है hash. Tamper proof, sharing, secure due to hash. So hash value obtained from the IPFS network and blockchain transactions. So after doing it, now we have to think about if this is what the problem occurred. Orphan stages and forking is nothing but what? Version control issues over there. So if it is what going to be happen, then this particular author has given or suggested algorithm inspired by the nature 40. Enhanced 40 optimization algorithm where he will explore, he will going to be find local or maximum minima over there. With respect to that, going to be select the blocks, and due to that going to be reduce the probability of getting orphan blocks. So when this is what the condition, what are the aspects are majorly assumed or considered? Fork mining, minimization. There shouldn't be a maximum amount of fork issues over there. That is what? Evaluation of impact the Ethereum blockchain. This is what implemented on Ethereum platform. So in case of Ethereum, if these issues are being involved, in that case evaluate the impact of Ethereum blockchain over there. Then transaction participation committee